Hello and welcome to everyone. This is RonakV from Toronto. I'm here to tell you a story about how we're going to achieve system reliability. Um, it's it's been time where we all have encountered DevOps in some way or the other in our respective organization. But now is the time when we start evolving and bridge the gap to achieving site reliability engineering, or more or less we can call system reliability for now. The reason behind I have a turtle in my picture on the first slide is I consider him as most reliable mammal out of the all in the blue ocean out there. So some way or the other we want to be more reliable, long lasting, ever growing, just like the turtle we have. Oh, it's 3:21 a.m. and John has already received a call. So this call is from offshore team who's working on a critical incident, and now John has been paged to look into it. What would John's thoughts look like now? 3:21 a.m. Things are going good. I'm in a good mood, or John is in good sleep. Slowly it's changing. He wonders, no, the system can't be down. Now he drills more deeper and looks into it. He finds out that, oh, the system is actually in a bad state. So he's going to cry out in distress. So this is John's story, why we need to have system reliability. So many Johns like us don't have to spoil our sleep. This is myself. Uh, it's COVID time, so shaking hands is not possible. So I'm greeting you all with a friendly namaste. Uh, and the only paradigm I want to shift right now is shifting the operations from passive to proactive. I have been working in the field of emerging technologies for almost 5 years now, and started as a software engineer, stored and slowly evolved more of a DevOps engineer and then a site reliability engineer. Currently, I'm working with CIBC and based out of Toronto. But all my passion always lies in teaching, conveying right knowledge to broader audiences, and that's one of the reason I'm in front of you here presenting the story of why system reliability is of the great importance that we are seeing nowadays. Let's go and hear it out. How would a typical SDLC look like? For doing software development, only the first step, which is ideation, is the random variable, whereas all other steps are pretty much constant. Idea can come in from any corner of your team, but then it has to go through funding. This funding is obviously given by your respective project managers or team leads, and goes down from there to gathering requirements, and now it's given to developer to develop it. Again, it's been shifting from developer to operations to do the necessary deployments in all the respective environments. Once the deployment is done, end client gets to face the product. And once it starts facing this product, you get all sorts of incidents, all sort of responses, all sort of feedbacks. So let's do a reality check on it. What is the end goal? From a developer perspective, the end goal is pushing the software out to production as soon as possible. Whereas an operations guy would be wondering, oh, I have to take care of the maintenance once it's out live in the market for everyone to use. But the reality is what happens when there is an incident. how us as an individual or a group managing this incident? Does it reach the right person within the short period of time, or how does the triaging is going to take place? Are the silos being shattered? Are people communicating more often? Are they discussing how this particular incident has happened in past and how better we could have tackled it? Is there a tracking system where this everything can get logged, where we can see all the known issues versus the unknown one, and obviously revisit them so we could automate most of them as and where it's possible. So this reality check helps us define reliability. What helps reliability is running, and by that I mean reliability is an outcome of a system to be able to sustain all the failures while remaining functional or pretty much self-heal without disrupting the services that are already running. So reliability should be a synonym of running, and that's how you're gonna achieve a reliable system or a software for your own company. We all have been doing DevOps now, and the topic of our presentation today is how DevOps is a bridge to getting into an SRE's shoes. Let's go deeper in this. DevOps, as everyone knows, is a practice and a framework for tearing down walls between different sets of teams. It has taken many forms or practices, I would rather say, over the course of year, and definitely in an SDLC format. It is how we empower each and every role, from that of a developer to that of an operator doing deployments. It has been a bottom-up approach that tackles how individuals work across the boundaries, how they are tackling all the incidents, how they are managing their time, how better or how good their product is in real world. And everything and anything about DevOps has been put down as a practice, as a framework, which people can follow to achieve a robust system. Now comes the SRE. Site reliability was defined at Google, and it has been always an, an implementer's dream, where SRE is all about implementing the practices that DevOps has already been defined for several years. It has been a combination of mindset, organization, a job for optimizing and operating mid to large systems. An SRE approaches DevOps practices with distinct skills and has less silos among its peers. It has always been considered that SRE has a top-down approach where it has to make sure that system or a product is empowered or ensured an uptime and is reliable enough to achieve 4 nines. I would take a pause to just quickly describe the 99.99% of reliability I mentioned in this slide. There has been a time where people had started migrating their softwares to cloud, and once the migration started taking place to public clouds, there were different sets of guarantees that were provided in terms of SLAs, and these guarantees would come in terms of uptime. And the minimum uptime an organization can expect is of 4 nines, which is 99.99%. Having 5 nines, which is 99.999%, is an ideal situation, and it can be achieved with with cost. So anything to achieve with reliability is associated with cost. Now, there is a quick distinguish between all the metrics that DevOps would measure versus the SRE would measure. DevOps is about lead time, which is a customer facing metric. It decides the time elapsed between between the order that a customer have placed or a system that the customer is using versus the response that comes from the system. So from DevOps perspective, lead time, then process time. Process time again is an actual time that a CPU clock would time in from a service being requested to that of that it's being offered. So lead time and process time are two good measures for DevOps from DevOps perspective. The third one and the most important one is percentage completion versus the accuracy achieved. Now, as I said, all these metrics are are good on paper or good in terms of analyzing a system, but what comes in real world is defined under SRE metrics, and it makes more sense in day-to-day world. SRE metrics would measure latency and error rate. Latency being that that once the request has been made from client's end, and the amount of time it takes for a CPU or a system to respond describes the latency. And there is obviously error rate in it. Error rate is actually the frequency of errors that are occurring and causing this latency. Second metric that has been considered by SRE is throughput. Throughput is rate of production or the rate at which something is being processed within a system. So throughput is in real time when a monitoring dashboard has been set up. Throughput will give you the output that how much time from the button being pushed to deploy till the time the actual software getting deployed is consumed by that particular system. So that way you can measure this throughput and decide how how many more CPU cores or how many RAM or memory you need to fuse in to make it or achieve a better throughput for yourself. So it's again in practical versus the theoretical metrics that DevOps would reach. The third important metric with SRE is availability and the self-recovery. Nowadays, availability has become a de facto metric for all the organization. It helps you boost your whole system and rising high and showing that you have a more stable, more robust, and more secure system. And self-recovery is a self-heal where your system is capable of spinning up a pod or a, or a container or even the application itself if anything goes down. So it's a sheer case of load balancing or having availability and recovering every time a system goes down. So with this slide, we pretty much can conclude that DevOps uh, is a theoretical part, whereas SRE is an implementation part of it. So let's see how SRE actually implements DevOps. SRE is, as I mentioned, is an action item that would come under DevOps practices, where there are a focus group of people who are doing operations and reliability work while being very much in proximity to the development team. Now, having an overall view of your whole system would termed as system engineering, and that is the focal point for all sort of problem solving that would occur in making the system robust and reliable. There are a lot of best practices that DevOps has been preaching over the years, and obviously it has a shared philosophy that that has been shared with SRE. But SRE has taken it a step ahead. This shared philosophy should be in such a standard that it's followed across the whole organization. This just not increases the notion of having unity, but it also unanimously promotes that you can take over a person or the knowledge transfer becomes very easy and seamless. And this could be achieved through the notion of common tooling or how you handle your budgets, or even having a better understanding of the SLAs and SLOs that has been defined by your teams. And I would say there should be an active desire within each and every team member to automate and enhance the skills among the teams. So that way they can tackle this issue of cutting down redundant manual tasks that we would do in day-to-day life. So until now, we have been discussing a lot about how SRE would implement DevOps and how SRE is actually a practical phase for all the theoretical part or practices that DevOps has been preaching over the years. Let's not forget the incident that had come at 3:21 a.m. to John, and now uh, that's actually sparked us to discuss the story about how SRE should be brought into picture to start implementing the practices that DevOps has been preaching. Let's move on to the wall of complexity. This wall of complexion is very common in every organization. As the incident happened, and John has answered or responded, I would say, responded to this incident, he reaches out from operations being responsible to acknowledge this incident. He reaches out to the developers group and asks for the real reason why this incident would have happened. Developer group responds back to the operations group saying it's been a change of functionality. Now, group being not aware of this change of functionality in the application is definitely not prepared for for a faster response on how to solve this issue. So it sends it back after the limited triaging it has done to the developers group. Now, the developer group has done the functionality. They would have never reviewed the requirements that is required to give the maintenance uh, information to the operations group. So not having enough information puts them in a jeopardized situation, and now they will send back the incident for more information. So the operation group has always been the one who are button pressers or like order takers, and they are less software defined. So they have limited idea about what exact requirements has been asked from the developers group. Having this limited information for themselves on the incident, they push it back to the developers group asking for a planned measure to tackle this. So now the reliability planned at the beginning is the only reliability been implemented throughout the development phase. Here is the problem. Reliability should be planned in such a way that it goes across the horizontals and just not remain a vertical in the beginning. So as we saw in the software development lifecycle, between the ideation phase and budgeting phase, reliability is being discussed, but it's never been brought up throughout the process until the deployment is done and the end client has been facing this product. Once the end client faces the product and now there is a bug and hence the incident has occurred, reliability is something will be blamed, and now paradigm shift. It goes back to the operation group, and operation group as always is unaware about the reliability practices and blames the architects, whereas in this whole scenario, incident has just been juggling between two different groups and builds up the complexity. The end result would be the incident not solved by developer group, neither by the operations group, and keeps on rotating until it reaches the backlog. So this has been the case for most of us in our day-to-day life. But let's see how this would be tackled if we are truly implementing DevOps through SRE. DevOps has defined itself as a, a set of best practices that will deal in bringing all the groups, be it development, be it operations, be it networking, be it security, together. And it obviously helps in reducing silos where there is people communicating with each other, breaking this wall of complexion. There is a plan in place to encounter all these failures. There are proper tools that get selected, and obviously people are made aware of the tools. If there is a knowledge sharing required, people are given right knowledge to handle those tools. Again, the steps are taken to automate most of the deployments. There is measuring and monitoring practices in place, and obviously smaller changes are always considered. Now, whereas this DevOps has been defining the practices, let's see what SRE has been doing. SRE takes this practices and puts some engineering capabilities to it and makes it altogether a robust, or I would say rather a reliable system for your organization. How it's going to help you reduce the silos? It will it will start with sharing the ownership with each and every individual involved from application development to application operation. There should be a failure plan, but how has this failure plan has been actually implemented? It's been implemented through error budgeting. People start infusing concept like error budgeting to help them start having the time frame for a particular change to go through, or at least a budget attached with the development, so there is no random development that's been happening and the money is not getting wasted. There is a proper tool selection. There is trials being conducted throughout the teams. There is POCs that has been promoted. There is monitoring and measuring, which is happening through SLA, SLO, and SLIs being defined across the board. And obviously, there are smaller changes that are happening with stability in mind. And the stability is for your end product that is going to face the client. And the reason you see here the two globes, where one being a globe ball merely sitting on the desk, whereas you'd see the SRE on the other side is the actual globe where you would see things in action. Now, the most important part of having a system engineering approach to your day-to-day activities starts with having the right mindset, and that's again a DevOps practice. A right mindset is where it all begins. SRE uh, sits on the very first step of having a system thinking approach. Organizations with organizational maturity are been using these engineering patterns to achieve higher throughput. There have been so many active gatekeepers which are disguised under reliability engineering to attain this production readiness. And last but not the least, incident management and operational issues are handled well by rejecting substandard software. So we need to always focus on at least standardizing some set of software, some set of tools across the board. And this comes with accepting no for some substandard software that are being brought in or infused through different channels. Can be through project managers, can be through our own architects, can be through the developers. So substandardizing should be stopped. There should be active gatekeepers, and there should be patterns that should be recorded. And the whole circle of system engineering, as you see from the graph, there's a lot of overlap where where SRE is actually bridging development and operations with the help of DevOps practices. John might be happy to see there are steps taken to help him not encounter such incidents in future. But how John can make sure that this is continued and taken to a potential solution in handling incidents? So the answer lies in having a shared responsibility. The shared responsibility begins with with planning stage, and it's a bottom up approach. So SRE work items, when you see from this graph, SRE work items are obviously defined with the help of DevOps practices. And again, I would repeat, it's going to bridge the gap between operations and development team members, cutting down the silos and helping them tackle incidents like this very easily. SRE work items now has been going for so long, but the flow is actually beginning. It takes place from the AD teams. They are the first point of contact for starting to work on SRE items. Ask your developers to take on some operations work. Give some responsibility to your developers. That way, The reliability objectives would be understood by them as much as the operations guy understands reliability. Take help from the developers in operational tasks, like make them do deployments, make them at least orchestrate some of the pipelines which does the deployment. This would help them understand or help them come into the shoes of an operations guy. Ask them to actively participate in on-call rotations, and also while triaging of incidents like this, the one that John has received, takes place, help make them take active participation in this. This will help them understand the situation much better. Ask them to join the bridge. And finally, application development team taking part in supporting this application operation team is what it will complete our aim of having a shared responsibility of ecosystem. And last few slides, I'm going to take time and define hope can never be a strategy. This is a very strong statement, and it's coming from an SRE perspective, because nothing can be left back on hoping that system is going to be self-reliable or it's going to sustain major backdrops. That's going to happen. Three things, or I would say three pillars that are going to help us define this statement is having SLO, SLI, SLA, and error budgeting. Second is toil and how are we going to eliminate it. And third, data-driven operations. Moving further, we're going to define SLI, SLOs, and SLAs and give some best practices on how you could do it better in your respective organization. Now, John has already learned this through a harder way, where he had to face an incident in middle of night and come up with this potential solutions of having reliability to begin at a very early stage. But let's not commit the same mistake in our own world and understand the importance of it. So an SLO, service level objective, would be defined as a ratio of target value for a specific service level indicator to that of a range measured over a period of time. Whereas service level indicator would be defined as an operating quantitative measure on how the performance of a service is actually been performed. So SLI is more ground level, whereas SLO is an is basically describing a user's need. So SLI becomes the one that is going to give users is going to describe users experience, and SLO is something that's going to describe users needs. Some of the best practices for both of them is being SLO should have been decided based on two threshold items, and those two threshold items are very crucial. One being, if your team capable of meeting those SLOs, then only define them. Don't put the things out and then ask your teams that would you be and make them achieve those SLOs. Things are not going to work that way. Make sure you discuss well before in advance with your team members and then define the SLOs. Also, the second threshold being, if the SLO is being just barely met, would mean your customers are happy. So this depends on different environment or different products that you are being working on. It's not the case with everyone, but this two thresholds is going to definitely help you set your SLOs. SLI is a quantitative measure, and it's going to help you define users experience, and it's based on two key metrics that SRE measures, as we discussed earlier. It's latency and throughput. It should be measurable, like SLIs that you set should be measurable. It should be observable by the users and should not just remain internal. It should be put out in the world where people can see what service levels you have set for them. That way you will be able to get active feedbacks, and it will help you define your SLIs in near future. Having talked about SLI and SLO, one thing that has been common through ages, which has been SLA, a service level agreement, and it's going to stay for many long years to come in future, because there is something that it's a kind of a contract where where uh, where it binds the services that to meet the SLO and provides user with a compensation if it's not being met. And the only best practice with SLA is it should be simple. Any loss of service would be equivalent to loss of business, and a compensation should be drafted out and provided if a SLA breach would happen. Second thing that's going to help us define the statement hope is not a strategy is toil and its elimination. In day-to-day life, from our work, we have been doing repetitive manual tasks which are associated with operations. This would pretty much define the toil, and it's something that doesn't happen overnight. It scales linearly with size of functions involved in system, which does not provide lasting value. So toil is everywhere. We would be facing it in day-to-day manual monitoring and logging system for health checks. We would do software deployments in multiple environments using simple Linux commands, and we would manually migrate data like files or copy paste config files. It's pretty much common when we are turning up service in new availability zone. And all this is prone of human errors. Let me inform you guys. Uh, Incident ticket management are common, as when user request for say one thing. If user is requesting one thing in a ServiceNow portal, the ticket is filled by ops guy to go and run the script that says one thing.sh, which is again prone to human errors. Is toil bad? How are we going to measure it? Maintaining system with toil is going to be very expensive. Over time, project team has less and less time to take on more important tasks as toil starts accumulating. It's been reported that 70% of the incidents are outcome of manual changes done by running the services. Toil increases the risk of regressions due to error-prone manual changes. Unhappiness and burnout of employees is an outcome of excessive toil. By now, you guys would have guessed it's definitely bad. But how are we going to measure this so that we do not do such, or we do not accumulate toil in our own organization? So there we should take help of project tracking tools like Jira, incident tickets. There should be regular health check done of not just the system but as well as of the team members to identify the hotspot when they commit to toil, or this will even help us prevent the burnout of the employees. Knowing the impact of high toil while working on toil reduction techniques can result in reduced cost and increase the team efficiency. Common standards across the organization versus the team to reduce the risk in actions like build, monitoring, and rollout. I would like to stress on this common standards across the organization. This has been very important and played a good role in Netflix. Reminds me of the days in late 2015. Netflix had this issue where they were having, Netflix has always had an uptime of 99.999%, and this was due to having robust systems, having proper load balancing, having less silos. Only thing that was not worked upon actively was having common standards. There were different set of tools being used, and in 2005 in November an incident broke and the issue was logged in one of the tools, and the same incident wouldn't reflect to the another team that was doing ad and marketing, and it was well out in public that particular show is already released, and the end credits, the error was the end credits were missing in that show and in one of their episode, and that issue was logged in another tool, and the same tool wasn't shared across multiple teams. So the team actually doing or responsible for having that end credits in place wasn't aware that this particular incident has occurred, and it lasted for almost 2 months before it was pointed out. So this lets us know how important it is to have common standards across the organization. Couple of things left in this presentation is how are we going to measure riskiness versus reliability versus velocity. Uh, and this is a build up on how a data backed operation or data backed decision is going to help us achieve SRE or help us define the statement that hope can never be a strategy. So velocity is something associated with development teams. They want to release newer and newer features as soon as it's possible. To catch up with them is pretty much not possible for the operation team because operation team has always been focusing on reliability. And the third thing that entitles reliability and velocity is riskiness, because there are so many random and unplanned changes that happens or are the reason for incident like this coming out. And summing up A, B, and C will lead to operation team never being able to decide on newer releases. That's why riskiness is very unpredictable in real world. So taking risk versus taking calculated risk is two different thing. And how to take calculated risk in SRE is is through data backed operations. Because once we start engaging our teams to rely on data to do their releases, it will change their thinking process drastically. They're going to think from a systems perspective, not just from one functionality. They will not be taking judgment calls any further. Teams will be relying on monitoring system, the standardized principles and softwares and tools across across the organization, and teams will be promoting reliability. There should be steps taken on infusing error budgets for the teams where they should uh, they should focus if the budget for the project is under error budget, new releases will be released, and if it's over the budget, just focus on monitoring changes or performance changes. To achieve this data backed operation, we need to focus on a couple of things. We need to log our past performances. We should try and match or even exceed the SLOs that we have set. We need to automate the failovers and error handling methods. We should try out we should try carrying out mini drills like infusing chaos monkeys or testing for those outages, uh, potential outages that would happen. And we should plan well ahead for disaster recovery. So let's uh, close the bridge for John. It's been a long night. Uh, Many of DevOps practices uh, like version controlling, monitoring, budgeting have already been adopted and implemented in small to big firms. Uh, so obviously we should start that phase if we have already not. We should start designing, thinking, or keeping reliability as the focal point. We should use our budgets wisely. We should keep dev and ops people in close proximity to get enhanced results. We should implement more and blame less. We should automate where and wherever possible, reduce the redundant manual task, and increase data-backed decisions. We should keep simple standards across the organization. Take accountability for SLIs, SLO, and SLAs that we set. And finally, we should remember to breathe. And thank you. That ends the presentation. I have tried my best to answer all the questions in a question and answer format through the story of how DevOps will help us implement SRE. Thank you and have a wonderful day.